All right, guys, here we go. Shh. Everybody, I need you to get a piece of paper out or whatever. We're going to do some sample questions here. Shh. I'm recording, so you can go back and watch this later. All right, so what I've done, guys, I need everyone quiet. My head's going to explode. I know you don't want to see that. Shh. What I've done is I've taken these questions, all the junk that we've been doing for the last week and a half, and kind of just asked it in a different way. That review sheet quiz that you had was just simply, here's a function, give me everything. Here's a function, give me everything. Now what the test I'm giving you Monday is going to pick out stuff. And it's going to kind of test your knowledge of lingo, the terminology, and understanding, when it's asking, do you know how to get the specific bit of information that you want, okay? So, first question. F of x equals x squared minus 6x plus 5. How many zeros does f prime of x have on a closed interval? Yeah.
That's my answer.
Oh. Gotcha.
I don't know.
Okay. You're right. And there's all kinds of little different intuition we'll talk about. So where does f prime of x have any zeros on this closed interval? Okay.
So you gotta get.
No, you have to find the first derivative and factor.
Yes.
Was the rule that it's the zeros is all exponent exponent to the highest degree? Is that the rule? No.
No, it's equal to the degree.
Okay.
Yeah.
So it would have 2?
No, it's 1.
It's 1. Okay, now we're going to talk about all kinds of ways to look at this problem. So let's really kind of break it down what I'm asking. Where f prime is equal to 0, when we did that, what is that telling me?
Potential extremes.
Potential extremes. We're looking for those possible max and mins. So what I'm really asking is first derivative, so we can do it old school. We get 2x minus 6. Set it equal to 0. You get x equals 3. Has 1, 0. Therefore, and that happens to be it. Okay, and we know that it's what? Is it a min or max?
It's a min.
It's a min. Now let's talk about old school type stuff from Algebra 1, 2 stuff. What kind of function is this? Parabola. Okay, it's a quadratic, absolutely. Okay, and quadratics are parabolas. Does this thing open up or down? So therefore it has to have a min. Okay? Those are little intuition like things that can kind of help you out on the AP exam. When you see questions, think of it. Look at it. Now this is a very basic type of sample of that, but sometimes you can think through some things like, velocities are always positive. When you're looking at the area of something, that's always positive. If you get a negative answer, we throw it away. Okay, we're going to do that soon. We're going to do we're going to take this stuff, and we call it optimization, and we're going to be finding some maxes and minimums of things, and you'll get negative answers and positive answers. Some answers won't make sense. Okay.
And you didn't think like that. Like how else would you be able to?
So I basically find the first derivative and set it equal to 0.
Yeah, the max and the min. Like how would you be able to test this max?
Well, you would test the interval. Now you could find second derivative, which is just 2. Excuse me. And is that positive or negative?
Positive.
There you go. It's concave up everywhere.
So it doesn't.
But you can't plug 3 into there, can you?
No.
So you really can't test. So you could do like this. 3, test to the left and test to the right. You'll notice that I have a negative and a positive here. Okay? Therefore, it's a min. But the concept here is what I was trying to get to. How many zeros does f prime have? Okay? And the idea is that, you would differentiate and you can set equal to 0 and actually count them. Now, Dean brought something up, and he said that how many zeros does a function have compared to its degree? They're the same. So, like in the original, this thing has 2 x-intercepts, or 2 zeros. Why? Because it's a degree 2. This one has how many solutions? 1 solution. So that's one answer. Believe it or not, that has 4 answers. Okay, it's 0, but what else? 0 and 0 and 0. We call it 0 multiplicity 4. Yeah, we would do like 0 and little m. I did like little m colon, okay? But that's called the fundamental, basically the fundamental theorem of algebra, that you've got that many answers based off the degree. Okay? All right, so pretty straightforward, pretty easy. We're just understanding that where f prime is equal to 0, that's our possible extremis. All right, number 2, here's a good one. It's not hard, but you're going to have to think it through a little bit. F of x is this guy, but I've got a k. I've got a constant, unknown constant here, k. I want you to find k such that f of prime, or f has a point of inflection at that x value. So just really put your thinking cap on. You got to focus and just start. I'll shut up. Well, it's hard to concentrate with me, Gavin. You got this. This is not hard.
Okay. Yeah.
You can do the 1/3 or math, I think. See 84 here. You can do to the 1/3. Raise it to the 1/3 as well. should be able to do this without a calculator. Okay. You're not going to like me very much, but I'm not going to allow the calculator on this test. Okay. I changed my mind because I'm doing the test. I'm making the test up, and I'm like, nope, because the calculator does it all. And I hate to say that. Okay. It graphs. I mean, what's the point of asking you to graph a sketch when you've got a calculator that graphs it for you? So we'll have times when you can use your calculator. I promise I've made these so things are nice. There's no goofiness. Okay. You're not going to have to really, trust me. The hardest thing on the thing is really, plugging in 2 into an equation. That's it. Okay. All right, here, let's go through this. What do we get? K is what? 2.
What?
Yes. Okay, good job. All right, let's talk about this. When I say poi, immediately that's talking about second derivative. So let's go ahead and find the second derivative. Now, before I start differentiating, let me rewrite this and make it a little easier for you to differentiate. Okay, I'm going to rewrite that as k times x to the negative 1. Then it's a little easier to differentiate. Y prime would be 6x plus kx to the negative 2. Y double prime would be 6 plus negative 2k x to the negative 3. Cleaning that up, that's really 6 minus 2k over x cubed. Now, what did we do? How did we find poise? We would take second derivative and set it equal to 0. Well, I found the poi already for you. The poi happens at cube root of 2/3. So I'm going to plug that in for x. So I get 6 minus 2k, the cube root of 2/3 cubed equals 0. Now I'm just going to solve for k. Well, the cube root of something cubed, they kind of cancel. All right, that's just 2/3. And what's 2 divided by 2/3? 3. Hopefully y'all can just see that. 2 divided by 2/3 is 3. All right. If you can't see that, we just make it like that, right? We take the bottom fraction and invert. They cancel and you're left with 3. Okay? So this is going to be 6 minus 3k. And then solving for k, k equals 2. So not very difficult, just you had to think through a little bit of algebra process and the definition of what poi. How did we find poise? Second derivative. Okay? Yeah. And see, again, everybody knows how to find a poi. We've been doing that. But I guarantee you, that's what I was trying to say, the AP exam will not just simply ask you to find the poise. Right? Unfortunately. In fact, everything we've done all year so far, you'll find none of these questions really on the AP exam. And what I mean by that is what have we been mostly doing? Differentiating. We've been learning all these differentiating. There is no question on the AP exam that says, what's the derivative of this? Maybe one. And if they do it, they're going to make sure it's a doozy. Okay? But it's all use it. All right? All right. Now, what some of the things we've done so far as using it is we've done related rates, found tangent lines, right? Those are on the exam. Okay? So they'll say, hey, what's the equation of the tangent line? Okay? So it involves differentiating, but it's, they're going to make you use it. All right, next question. Y equals 2 over 5 minus x. This is concave down on what value of x? On what intervals, I should say. On what intervals of x?
So once you define the interval.
Yeah, what, in other words, it's going to be a range, like interval notation. You're going to give me a range of x's such that the graph f is concave down. If we were to curve sketch this thing out, on what intervals, where would it be concave down?
Okay, so basically, just sketch it down.
You don't have to actually sketch it. We're going to do some math here.
So,
It's okay. Part of the battle is understanding what the question's wanting. Okay, let's kind of let's get started here. Again, what helps us determine concavity, or what? Second derivative. So let's go ahead and get that out of the way. Y equals. Now I like differentiating using chain rule. So I'm going to rewrite this like that. Okay, so I don't have to use quotient rule. All right, here we go. Y prime is going to be power out front, leave this alone, subtract 1 from the power, times the derivative of what's inside there, which is a negative 1. So that cleans up to a positive 2, 5 minus x to the negative 2. Okay, that negative and that negative undo each other. All right, second derivative. Negative 2 times out front. So that's going to be negative 4. Leave that alone. Times the subtract 1 from the power. Times the derivative of what's inside here. Okay, so that again undoes the negative. So it's 4 times 5 minus x negative q. Now I'm going to go ahead and put it back to normal without the negative exponent. There is. Where? There's a vertical asymptote at. Yep, we determined that from the original. Where is the original undefined at? At x equals 5. All right, now we'll look at second derivative and we set it equal to 0. It can't be solved, right? Because the numerator is constant. So there's no way it could be 0. So therefore, the other way we can determine a possible point of inflection is where it's undefined. And in this case, it is undefined at x equals 5. So now we do our little sign chart, and I'm going to test to the left and test to the right. Now we know there's also an asymptote there because of the original function. All right, if I take a value to the left of 5, 0, I'm going to plug it into my second derivative. I basically get a positive answer there. And if I plug in a 6, I'd get a negative. So where is this saying concave down? X is greater than 5. Why is it not equal to 5? Greater than or equal to 5? Right, because what happens, it's undefined there. Now let's say it was defined there for whatever reason. Okay? It can't equal anything if it had a horizontal tangent. Okay? So generally points of inflection. Like here's a point of inflection on here. Notice what happens is that the slopes come up, and all of a sudden, it will actually look like a horizontal tangent. Okay? So, yeah.
If it is defined, will we include the 5?
Yes, if it is defined, it can happen there. Now, the point is, though, the question is asking, is it downward? what happens is at the points of inflection, guys, it has no concavity at the point of inflection. So it's always greater than, it can't equal that number. Okay, whenever you find a point of inflection, guys, it has no concavity there.
So never greater than.
Correct. In other words, it can never equal, if you're looking at your intervals, it can never equal, it can't include the point of inflection. Because if you look what's happening, I've got all these tangent lines here, and all of a sudden it planes out. Yes?
So wouldn't it be it's concave down?
No, it's concavities where second derivative is negative.
Wait, is that skips the graph?
No, I'm sorry. No, I was talking about, the question is, the answer is x equals 5. But can it ever be x equals greater than or equal to 5, or whatever the poi is? And the answer is no, because at the poi, there is no concavity. You're switching from still water to whole water, or vice versa, but that's like the crossover point. It's like a black hole. It just goes to nothing. There is no concavity. Okay, so
I was getting confused with that sketch.
I'm sorry. Yeah, I was just trying to show you how you have a tangent line. Yeah.
Where'd you plug in to find the intervals again?
I plug in second derivative. Second derivative describes concavity. Now, you can find out if what you would do, you would take first derivative, set it equal to 0, or find its, whatever, and you can figure out what's going on. The problem is, I'd take first derivative, I'd set it equal to 0, and where it's undefined, I'd get 5 as well. And I can't plug 5 in because I get undefined. So second derivative test, there is no max or min, guys, by the way. All right? But there is, a point of inflection. So this one would not be a good case. Second derivative test for max and min wouldn't work. Okay? All right, guys, here's another type of question. Which one of these 4 graphs could represent the information given? Give some letters to it. This was pulled off an AP exam. This question.
Is it one for each, like one graph for each?
No. This is all the data given, all the information. Which graph can fit that data? Survey says, hey. All right. Let's see why. What I'm really saying, first derivative talks about increasing, decreasing, and this is positive, so that's saying this function's increasing. Second derivative is talking about concavity. This is telling me second derivative is negative, so it's concave down. So where is it? Increasing, concave down. Increasing, concave down. Okay? This one would be, all right, so that's this one. Describe this one. F of prime and F double prime. F prime would be what? Positive? Positive. What would this one be? Negative, negative, and this one would be? Perfect. Negative, concave up. Excellent, guys. Good. Okay, just go with your gut instinct. Know the fundamental definitions that you've been learning here. All right, f of x equals this function. Give the coordinates of the extremas. I want to know the actual coordinate of where it occurs. Where it occurs. I figured this kind of stuff would. If I didn't think this stuff was so important and had so much impact on the AP exam, I would not be beating this up like this. But literally every one of these questions was on a single AP exam.
Wow.
And there's still more. These were on a real AP exam. I forget what year. I got to go look it up.
Oh, wait. Did they say give coordinates in order pair?
Coordinates in ordered pair. So I need the actual y value as well.
How many are there?
Hmm?
How many are there?
I don't know. Met your mom the other day, Abby.
Fine.
Yeah.
Yeah.
She's helping out doing some event planning.
Yeah, she
Yeah.
just got a job here like 2 weeks.
Nice. I just set her office up.
Yeah.
She's out in Timbuktu.
Yeah, so it's like
Yes.
yesterday.
When you do something like that, right?
Yep.
Like the X, you plug it in like the first derivative or the original? I'm trying to get something here.
You tell me.
The original.
I want you to really think and answer that. Have a reason why you do things. Remember,
Your-
all this garbage that we've been doing, guys, describes the original function. All the x values and all the y values that you get are actually points on the original. So yeah, the original.
If you got your points and you plug it back into the non-original.
Yeah, it's just giving you data. Yeah, it give you other. Remember, we're not trying to graph the derivative. We're not trying to graph the second derivative. We're trying to graph the original function. And first derivative, second derivative gives me all this data about the original. Yes.
So basically, first derivative and second derivative give you the x value, but you have to look for the y value in the original.
Yes. Okay.
What about when you plug in the first derivative right there?
Well, when you do plug in things in first derivative, second derivative, you're getting. What do we normally use that for? Sign charts. Yeah, we're getting data about the original. Everything's about the original. Guys, here's first derivative. We get 2 times x plus 9 to the 1. Okay? Times 1. And so that's really just 2x plus 18. We set it equal to 0. We get x equals negative 9. That's where a possible extrema happens. When we take negative 9, we're going to plug it back to the original. Because I want to know what's the actual point. And negative 9 plus 9 is 0, so the coordinate is negative 9, comma 0.
I did it wrong, but I got it right.
Okay.
I think I added one instead of subtracting.
Okay. And is this a min or a max?
That is the
It is
Max.
a min.
It's a min.
Yes.
One of those is right, Amelia. All right. Let me give you some intuition. It's a parabola, right? It's quadratic.
Yes.
There's a positive out front. This thing opens up.
All
All up parabolas always have a min. Okay? That's an intuition kind of way to hack through the answer. Okay? But we could do a sign chart. And this is where I'm taking first derivative and just getting data. All right? If I pick a number left of negative 9, like negative 10, all right, I'd get a what? Negative. And then I get a positive over here. So that means I'm decreasing, I'm increasing. Okay? I'm plugging into first derivative to give me data about the original. But at negative 9 zeros is where it actually occurs. Okay?
Also, you don't plug in back to 0. Like, you don't get 0.
Well, if I put negative 9 in the original, I do get 0.
I just figured about that.
Yeah. Okay? Genesis? Yes. Any other preguntas? Yes.
Don't you get a positive when you plug in something left of negative 9?
Well, no. Negative 10 would be negative 20. Negative 20 plus 18 would be a negative. Okay? It's all right. No worries. All right, here's a good one. This is like that table thing, guys. There's all this data here. What's that about? Okay. Gotcha.
Thanks, Mark.
Here's all this data about a function. Give me a basic curve sketch. Okay, take your time.
I will take my time.
No, I'll give you 3.8
It's like fast, man.
minutes. I'm just joking around. Take as long as you need. I had an old neighbor. He was an old guy. He was very funny, and he would say stuff like, I'd go, I'd go run to the grocery store real quick. And he'd go, why don't you drive? It's a lot quicker. I'd go getting a haircut. He goes, which one? He was witty like that, nonstop.
Like a haircut, like a single thing.
You actually get hairs cut. He worked a night shift he retired from New York. He was a customs agent at LaGuardia, and he worked the night shift. And his wife was a teacher, and she worked, of course, days. So they never hardly ever saw each other, and they said they'd always have fights with sticky notes. So because they would never actually see each other. He's coming home when she's going to work, and then she's coming home when he's going to work. So. There's some interesting parts to this. So really kind of come up with a conclusion. And if you're not sure, take a guess. Something weird is happening at some of these points. So you can kind of figure out what's kind of going on. This one was not, I did not pull this one off the AP exam. This was just me doing a chart. But they may have something like this. Possibly. We don't really know. I don't know. Feels right. I got home a little late, but I sent you some problems to try in an email.
Are they odd problems?
Well, I give you a batch. You can choose the odd. It's on page number. All right, I'm going to start. Anybody want more time? Think you're close? You want to keep going? Okay, go ahead. Oh, yeah. Probably won't. At
This is less than 2.
this one? This is saying second derivative is negative for everywhere but 2.
No.
Yeah. Oh.
I understand. I'm talking about the top. X is less than 2.
Oh, this one. Okay.
I miss algebra. My boyfriend's been like these, and I'm just like, I hate you so much. Like, yeah, I don't have 90. Like, I love you.
Yeah, there's a lot of insecurities in this class. All right, here we go, guys. I'm going to keep going. All right. So what's kind of happening? Do I have any more? Yeah, we'll finish on this one. All right, let's go with what we kind of got here. F of 0 is 4. So they just basically say, we've got a point here. And then f of 6, 2, 4, 6. We've got something going on there. All right, first statement. It's saying that the first derivative is negative for everything left of 2 and everything right of 4. First derivative less than 0 means it's decreasing, okay? So if this is 2, that's 4, 6. So everything left of 2, I'm kind of decreasing. So I'm going to draw a line first because I don't know concavity yet. Really don't understand that part. And I'm increasing everywhere to the right of 4, okay? Whoops, my bad. So I've kind of got, since I got to cross through this point, I've kind of got to do this. F prime of 2 doesn't exist. All right, so that could be an extrema there. Okay, so I could have some kind of extrema there because that's one of the ways we would find extremas, where its first derivative is equal to 0 and where first derivative is undefined. F prime of 4 is 0. Right off the bat, that tells me what? This is an extrema up here. First derivative set it equal to 0. Okay? Now, looking at this, I need to kind of fill in the gap here, what's going on here. This is saying first derivative is positive between 2 and 4. Yep. So this is a max here. Now I've got to kind of piece together some of my curvature here. This last one is saying that it's basically second derivative is negative for everywhere but 2. So it's concave down everywhere except 2. So let's kind of start getting my curviness here. So I see this part. Now it's concave down. Whoops, concave down. Concave down. Concave down. That's the graph.
Okay, so what does it mean by DNA?
Does not exist.
So yeah, so like.
So I've kind of got here. Remember, how did we find possible extremas? Maxes and mins.
First derivative equals how you find the max and mins?
Yep.
You do the test for like the second derivative.
Correct. Well, you could, but it's basically what? Where first derivative is equal to 0 and where first derivative is undefined. This is saying first derivative is undefined. So I've got a possible extrema there. The problem is it doesn't come to a nice, pretty curve because of the concavity issue. All right? 2 is an extrema, guys, because it changes from decreasing to increasing. Remember the technical definition of an extrema? It's where it changes from increasing, decreasing, and vice versa. See, I'm decreasing, now I'm increasing. It's just because it's concave down, I can't have a pretty curve here. I can't do this. All right, I'd have more poise. All right? But based on this information, that's really all I can kind of draw a conclusion. If you drew an asymptote through 2, kind of technically that's wrong because they didn't tell you that. They didn't tell you F is undefined there. But I could accept that possibly. They would never do that to you. They would never give you this graph and recreate that graph and put an asymptote because you really can't tell.
But it's just as much an asymptote as a volt, right?
Mm-mm.
Why not?
Because I can actually take on the value. I can probably find F of 2.
But
There's a difference. An asymptote, the original function can't take on that value.
we don't know the original.
We don't know the original function. So on this one, you could probably conceivably draw an asymptote.
And then I put my max at 6 and made the asymptote like a downward parabola. We don't have.
Well, here's your max and min right here. First derivative is equal to 0. So at 4, we know there's an extrema. And based off our information, we can tell it's a max.
But wouldn't it be on the? Wouldn't it be on the
No, these points are on the actual graph.
Yeah.
This is what tells me what's on the actual graph. F of 6 is 0. But this graph could keep going here.
Why?
We don't know. They didn't give us any more information past 6.
Does it matter? Like, say you put the 4, like the point for 4 at 1. Would that matter, or would it not be a max?
How do you know where to put that point?
Well, for one
So
thing,
passing through 6.
yeah, it could go up there. I don't know. I just kind of threw it up there.
Okay, so
Yeah, notice I didn't have a y coordinate for this max here. The only true points I know is this guy and this guy. I mean, this part could have been more like that. So I don't know. Okay.
Is it really a max? But it has to be.
It's still a max. It's a relative max.
Oh.
It's changing from increasing to decreasing. Guys, that's the true definition of a relative max or min. It's where it changes, increasing to decreasing, and vice versa. Sophie, sorry.
How did you know? Oh, you just changed it now.
Yeah, I don't know how high it goes, guys. I just kind of threw in there.
Okay,
I
thought
made
there was a
6
weight,
the max.
so-
That was my.
Uh,
I made 6 because I go 6 0. It just has to be. But I didn't see the F prime. I thought the F prime was just F of 4 0.
oh, I see.
No, I didn't really see that.
You didn't
So I
see the
was
prime.
It's just
Yeah.
kind of confirmed. It was just kind of weird.
Yep. All right, guys, we'll do some more. I'm going to make some more problems up tomorrow. Maybe we'll have I don't know, an algebra day. I'm stuck because I can't give a test tomorrow, Friday, because y'all are. Hey, half of you won't be here tomorrow. Who's going to the law thing and the open house thing and all that?
Yeah.
Yeah.
Yeah. So I probably won't see most of you tomorrow.
You'll see me and I'll be equally as confused.
All right, guys. See you later.